can actually look at what it does. It talks to images.data.php. Some versions of images.7 PHP bserv, depending on the malware type. A certain groups title msits, msys, and then there's, you can track different groups that have different names for the executables. They usually redo it because phishers take the path of least resistance in most cases. And then we basically put together some bleeding edge snort rules. We actually made a bunch of them, but I didn't want to fit them on this slide. But two very important ones, we actually tried on a major that is a partner with us. Basically, we put in FSG detection. And what happened was, within 5 minutes on a very huge ISP, we found about 20 pieces of malware in 5 minutes. And only 2 of them were actually Hackstore. The other one were Brazilian, Australian, and Russian-based malware. So none of it was a false positive. We actually had very good success just pulling out FSG alone. And so we actually can rid a certain space of malware that's used with this packer. And so that's actually kind of neat. So now we know how to recover the data, but do we know how to prevent future form grabbing? So thinking outside of the box here, we were trying to say, hey, most people's anti-malware solution is to give something to the desktop or the client user. The problem with that is that when you're compromised, you must consider that localhost has no integrity. And when we look at Hackstore, we see a list of zone alarm, semantic Sophos, all this stuff getting shut off, and that's common. It's that arms race that we basically deal with. And so eventually, if you have a threat to them, they'll just put it in the list off your firewalls or whatever you have on. So we were thinking, okay, we need to find a way to do this so that it's on the server side. Basically kind of Sun Tzu's art of war, take the higher ground. And then basically the idea is this, and this is not a silver bullet, we're not saying it is, it's basically something that will push them to about a year or two to evolve, because it's like spam assassin. As it becomes a true threat, they do start looking at, oh, let me test my spam through spam assassin because it does affect my business. At this point, this technology would probably buy us years, before they evolve and you look at it as a serious threat. But basically what we do, this is the bank I use on a daily basis, First Bank of Phishing. And what we do is, to the normal user at home logging into their system, they don't see any difference of what's going on. So using live HTTP headers, just to show you, we actually encrypted this with an encryption algorithm. You can use whatever you want. But what happens is the JavaScript, we use JavaScript to basically send a key to the browser, but we use an extra namespace and put it in memory so that it's not just in the code, because Hackstore and Nuclear Grabber already grabbed the code of the page. This is why a site key is broken with Hackstore. But basically, we send a key to them. It's random. It only lasts 45 seconds. And what will happen is when they hit submit, it actually encrypts it at the JavaScript layer, HTML layer, sends it off to the server, and we have a decoder on the other end. And so when they do steal it, we basically assume localhost is already compromised for everybody, because the customer is the weakest link in the chain. And so you see this data here. This is obviously not Lance log, a bunch of, an IV and then the actual cipher itself. So it sends it. So when these guys look at it on their blind drop, they'll go, oh, gibberish, keep moving on. Because we saw there's a lot of gibberish in their drops anyways, whether it's encoded with something or just things they don't understand. So they'll just move on until it's like almost every bank has it, and then they'll be like a little bit ticked off about that. But so other things that we've been doing. Many phishers track their stats, whether it's a spam site that they want you to go to, like Viagra or whatever, or even in the malware we're seeing. And there's a lot of Russian groups that use hotlog.ru. Hotlog is basically a logging service, just like GeoCities has it's basically conversion rate. So what will happen here is we went to the Hotlog site to check it out, and it has an example thing of ustat / ID 23052. And so when we see a phisher's, either in the binary or actually using on a phish site, what will happen is they'll have their own ID, and they have a login and password and everything, but actually took the example site and put the other ID in there. It bypassed the login and password, and basically allowed us to just look at their stats. This has a lot of good things for us, because what we call victim zero is the phisher itself. Basically before the first victim gets hit or infected, we'll see first hits before the mass distribution, and we'll see like 50 IPs of the same IP coming in from Ukraine. How many times are you going to infect yourself with this malware? So most likely that's our phisher right there, and so we'll see that, and it's also sold because of the fact that we'll also see another 50 coming in from somewhere in Nigeria or somewhere in Australia, and it's very unlikely that the same person is infecting them themselves constantly, because as we go down the list, we see these victims and they get hit once, and then you can keep track of it. So you can see the mass hits, the geographical location of these hits, and you can see the victim hit statistics and IP information, so you can get an idea where's the high rate of infection. Now the cool thing about this is that these phishers are using this to also know this themselves. The newer malware like MetaFisher and VBreeze is actually also keeping, they have actually a blind drop site that actually keeps track of all of this stuff for them. Web attackers the same way with the exploits. Web attacker is an exploit tool that basically has a bunch of brute forced exploits, and they keep track of which exploits are the most effective, what regions are getting most effective. And so these fishers actually do us a good job, a good service, because we can keep track of what they want to do, and they do all the work for us, which is good. We actually wrote an article in 2000, one of the first phishing groups that hit major banks. This enabled us to locate the tester a week before the distribution. We tracked all the referrers. We got idea of how many victims got hit from this site, and we located the scam kit developer that lived in Tybot's Corner, Delaware, which we ended up calling this group the Delaware Phishing Group, even though they're a Russian organization. Fun with IRC. I'm not going to mention the IRC server that this is the vulnerability to, but anybody who's clueful and probably figure it out. Basically, we tracked down the Dephonic crew by accident. I'll tell you offline how that happened. But basically what happened was we ended up landing on irc.dephonic.net. If anybody knows who the Dephonic crew is, also known as localroot.org, they did the LexisNexis hack and the Paris Hilton's mobile sidekick where they posted all the email up on a site. They were using cloaking encryption, basically part of this server. So what would happen is it hides the IP of the channel users. Here's some pseudocode just to give you an idea. So basically a 96-bit key divided up in 32-bit words, three 32-bit words, and then you would have your function for the IP address to actually encrypt. Your output would basically be some hexadecimal sets of 4, and then with an X depending on, it could be .ip, it could be X. It's really, it doesn't really mean anything except for, here's my parsing or whatever. And basically we looked at the algorithm. It was basically a CRC32 variant. It's a very linear algorithm. We basically decided to, see can we attack this. So we basically did what's called a related key and divide and conquer attack. And basically, the funniest part about this code is that it was an open source piece of code. So we looked at the cipher, and it had a double XOR in there, and then it had a comment that said to keep crackers from cracking this encryption. If anybody has any background in XOR or encryption alone, you know that what a double XOR does just is reverses the problem. So their 96-bit key just suddenly became a 64-bit key for us. And then we did a divide and conquer attack, and this reduced the key to a search space of 2 to the 30th. I don't have my exponent in there, sorry guys. And then reduction of search time by a factor of 2 to the 66th. The new output, we got basically a IP address, and the key was broken within 5 seconds on an AMD 64. Fun with IM. Everybody have Trillion or know what it is? Yeah, raise your hand if you do. Basically, the background of it is basically it's a multiple, like game. It's like basically a commercial version. There's a basic version and a pro of just IM. You can have AIM, MSN, Yahoo, blah, blah, blah. Like a while back that they have secure IM using 128-bit industry standard encryption. They were kind of right. Basically what happened is they are truly 128-bit. How many people understand Diffie-Hellman in here? Okay. Most people understand that in discrete logarithms and large number theory you need large primes. You need safe primes and large primes. Well, they did do safe primes. They actually did Sophie-Germain primes, which is the proper way of doing that. Quickly speaking, basically a Sophie-Germain prime is basically you take your prime, you subtract it by and divide it by 2, and that should be also a prime. This stops things like baby step attacks, Poly-Hellman attacks, things like this, and a lot of general number field kind of sieve attacks. But the actual primes themselves were 128-bit. And basically, just to give a background on that, IETF Oakley primes have to be, group 1 is 1024, group 2 is 1536, and group 5 is 2048-bit primes. The highly recommended prime set for the lowest is 1536, the group 2 primes for 10-year space before you have to revoke a key. In this case, if you're the NSA or anybody bored, you could probably do a cooked prime attack on 128-bit space because there's not that many primes in the 128-bit space. So you could actually cook all the possible keys for this. And also another attack, which if you want to go offline, it's kind of a complicated attack, but there's an index calculus attack you can perform. The basic idea is you create a linear sieve of all the prime minus 1 divided by 2, that second prime you get when you divide it. Basically, you take it and you get all the primes up to that number, and you basically calculate smooth relations against that, and then you can basically have all the possible keys for that prime. So for a passive attack, you can basically solve this problem in 1 hour, and if you want to do an active attack, you can do a man in the middle anyways, because they don't know anything about actually distribution of Diffie-Hellman. So many phishing groups that in Russia we see using Trillion because they think it's actually secure. So that actually helps us when it comes down to passive analysis, or any kind of law enforcement if they're doing passive analysis. All right, I'm going to let Josh continue on botnets.
How's everybody doing today? I'm Josh Bashairs. I'm an investigator and a researcher with Secure Science Corporation, and I'm going to talk a little bit about botnets and some of the other tools that phishers are actually using. Let's see. So a botnet is considered to be typically a compromised host or a series of hosts used for phishing or for denial of service attacks or for transferring wares or any number of malicious purposes. Eggdrop is a really popular IRC bot. It was originally written to add functionality to IRC, such as trivia or just interesting reports, slashdot headlines, what have you. And then there was another one called Energy Mech, which tended to lend itself a little bit more towards malicious purposes. It was a bit more modular, had an easier configuration, but didn't seem to catch on quite as well as Eggdrop. Interesting thing about these botnet files, the configuration files tell you a whole lot about the group that are actually using them. If they are configured correctly, then they can be almost useless to the researcher, but generally they're not. They're created out of haste. They don't have too much thought put into them, and you can usually infer ideas or items like the geographical location of the attackers. You can tell by the bot master, the person who's in charge of controlling the botnet, will have a host mask saying, only allow me to control this botnet, and typically that'll include an IP address or a host name, which you can then geolocate through various tools online to have a pretty good idea of at least where they were coming from or where they expect to come from the future. Other thing is password hashes. One with their geographic location, or have a pretty good idea of where they're coming from, then we can infer which language files that we should be using for brute force password cracking attempt, and generally they tend to be pretty successful. Phishers don't put too much thought into their passwords. It's more of a secondary thought. They just want to get it up and running so they can increase their profit. So here we're looking at a bot configuration file that was written entirely in PHP. This one's a modified version of DemonBot, and we can see a couple things like the undernet node that they're connected, which is in Montreal, the username of the bot, which is Fishsticks in this instance, and the port, which channel they're going to. And then there's a tagline on here that says, testing by GeoShell's team owned by Geonisi. Geonisi is a hacker out of Georgia, the country, not the state, and he is pretty proud of his abilities. But you can see his password isn't exactly the most cryptic or long password. Yeah, so that didn't take long to get into. Here's another sample of a configuration. This is, for brevity, we've trimmed down just the important stuff that we as researchers actually care about. You see the host that he's talking about. Anybody that knows the password and has their username as telnet in their IRC client will then be granted access to this bot file. And then we've got the username Geonisi, so it's Geonisi at telnet at whatever the host. And then we've got the encrypted password hash, which we can use various European language files and brute force. I don't know if you can read this very well. An output of a simple bash shell. What we ended up finding was, after tracking down a couple botnets and running them through Nmap and the whole kit and caboodle, port 5000 was open, which I thought was pretty interesting. A higher number of ports tend to yield more interesting results because you don't need administrator access to open them. And in this case, it was an unpassword protected backdoor. Anybody who bothered to tell me it would be free with the prompt. So a simple ls-lh showed a series of botnet configuration files, which had some interesting results. Our Fisher here didn't think it wise to remove his bash history file, and so we get a pretty good idea of what he was up to. Yeah, Perl, udp.perl, he's using UDP floods, so this guy's obviously elite. He's got his Unix COD botnet exploits and his floods. He's kind of clueless. What's going along here? Google hacking, if you haven't seen Johnny Long's talks about Google hacking, then you're probably pretty new to the industry. But result,